In this video, you're going to learn how to identify the range of valid IP address that we can actually assign to hosts on each of our new custom subnets. And here's the opt-out questions for this video. If you can answer all four correctly and you're comfortable, I'll see you in the next video. For most people, however, we are going to have a fantastic time right here, right now, as we identify how to quickly and easily identify the range of valid IP addresses on any of our given subnets. Let's begin. In our previous video together, we identified the individual subnets that can be created, and in this video, we're going to focus on the valid hosts that would fit on those subnets. So to do that, let's go ahead and use an example of this topology. We have 3 subnets that are required so far. Let's add a few more. Let's add a network out here, 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 and here. So we'll need a total of 1, 2, 3, 4, 5, 6, 7 subnets. So let's say we have a /24 network to begin with. So x.x.x.0/24. Now, do you get it that these first 3 numbers are going to be the same across the entire board if this is our major network? So we're going to start from that point. We're going to start stealing bits from the host portion, which is the last 8 bits. So by using the finger game, we can calculate that we need to steal 3 bits. That will give us up to 8 subnets, which is enough for our topology right here. So our new dividing line is right there. Our block size is 32, and our subnets are going to be subnet 0, subnet 32, subnet 64, subnet 96, subnet 128, subnet 160. Again, we're just adding the block size to each one of these. Subnet 192, and subnet 224. So here are 8 of the possible subnets that we could create. We're only going to need 7 of them. So over here, for example, we could have this be subnet 0. This could be subnet 32. This could be subnet 64 right there. This could be subnet 128. Subnet 160. Subnet 96. I didn't mean to leave him off. And over here, subnet 192. So those are our subnets, and of course the first 3 octets would be XXX, meaning they would be whatever they were over here, followed in the last octet by this value. So let's say we've identified these subnets, we know where we're going to put them, and we want to go and configure an interface. For example, let's take a look at serial 0/0 on router 2. We go into interface configuration mode, we want to configure the actual IP address, and then we realize, oh my goodness, what are the valid IP addresses that are on subnet 128? And the focus of this nugget, this video, is to go ahead and walk you through the very straightforward process of identifying exactly what the valid IP addresses are for subnet 128. And the process is right here. You're going to start by listing the subnets. So here we have all 8 subnets. And I have the S in plural because you don't have to list all the possible subnets. You can just go ahead and start listing the ones that you're going to be using or the ones that you're concerned about. And again, we're going to use the block size to determine our subnets. Once we have the subnets listed, and we're interested, for example, in the range, let's go ahead and take subnet 128 as an example. The very first host, the first valid host IP address on a subnet is going to be that subnet plus 1 in the very last octet. Now in this case, we're already in the very last octet right here. So for the 128 subnet, the very first host is going to be 129. So I'll call this column right here first host. Now I want to ask you a question. If 129 is the first host, do you think 130 is also a valid IP address on this subnet? If you're saying, yeah, Keith, it sounds like it would be. It's right next to it. How about 131 and 132 and 133? And if you look at the numbers, everything that is lower than 160 is part of the 128 subnet. If we go high enough, we're going to bump into subnet 160. And the reason that's important to know what the next subnet is that the range of IP addresses on the 128 subnet will never go as high as 160. Why is that? Because 160 is the next subnet. So if we wanted to calculate all the valid IP addresses on the 128 subnet, the very first host would be the subnet plus 1, and the very last host is going to be the next subnet right here. I'd like you to read this with me. The last host is going to be the next subnet minus 2. So if this guy's 160, if we subtract 2 from that, the last host on the previous subnet is going to be 158. Now, the first knee-jerk reaction is, why? why do we have to subtract 2? Why can't we just use like the next subnet minus 1? And the reason for that is the next subnet minus 1 is the broadcast address for the previous subnet. So the first host is this column. The last host is right here, and the formula for that is the next subnet minus 2, and the broadcast address is going to be the next subnet minus 1, which is 159 in this case. So what that means to us, if we want to configure the IP addresses here on subnet B, which is more specifically subnet 128, the valid IP addresses that you and I could choose to use for any device on this network, and I'm laughing because there's only 2 here, but the range of IP addresses could be anywhere between 129, so x.x.x.129, through 158. We couldn't use 128 because that's the actual street name all by itself. That is the subnetwork address. First valid host is 129, last valid host is 158, and regarding this subnet right here, the broadcast address that we would associate with this subnet is 159. One more IP address higher, and we're looking at the next subnet. So let's play that game again. And what we're going to do is we're going to use this formula right here, and let's pick on this subnet right here, subnet 192. So my question for you is this. What is the first valid host on the 192 subnet? What is the last valid host on the 192 subnet? And what is the broadcast address for the 192 subnet? So on the 192 subnet, the rule is that the first host is the subnet itself plus 1. So for the 192 subnet, that means the first host would be 193. The last valid host on this subnet is going to be the next subnet minus 2. Well, the next subnet is 224, so minus 2 would put our last valid host at 222. And the broadcast address for this 192 subnet is the next subnet minus 1, which is 223. That's it. That's how you calculate the valid range of IP addresses on a given subnet. So what I'd like you to do right now as your first expert exercise in this video is I'd like you to write down these 4 steps. List the subnets. The first host is the subnet plus 1. The last host is the next subnet minus 2. And the broadcast address is the next subnet minus 1. As you get more and more experience, you're going to be able to take additional shortcuts. But if you're new to this, having this process in mind of exactly what to do first, what to do next, that will assist you in identifying the valid host addresses on a given subnet. So take a moment, pause me, and write out these 4 steps right now. So let's you and I do another exercise. For our requirement, let's say that we have a /16 to begin with, and it really doesn't matter what those first 2 octets are. If the initial mask is 16, that's what the initial mask is. And let's say we have a requirement to create 15 new subnets. What I would like you to do is I'd like you to go ahead and list the first 4 subnets and their ranges. The ranges for a valid host address on those first 4 subnets. And for bonus points, go ahead and include the broadcast address for each of those subnets as well. So just to be clear, we're starting off with a /16. You need 15 new subnets. You're going to list the first 4 subnets and their ranges of valid hosts. Go ahead and pause me and do that right now. All right, welcome back. I'm curious, how did you do? Were you able to put all the pieces together? Here's how I would approach this. I'd say, first of all, we have this /16 network. Great. We need 15 new subnets. So, of course, we're going to do the finger game to identify how many bits we have to take away from host addresses to create at least 15 new subnets. The answer to that is 4 fingers, or 4 bits. And that new mask would look like this. There's our dividing line. There's our block size of 16, and the first 4 subnets would be 0 for subnet 0, 16, plus 16 more is 32, plus 16 more is 48, and that's all I asked for. It was the first 4 subnets. Now what's different about this than the last example is we are working in this 3rd octet right here. So this byte of data that we're cutting into, the host portions, represents the 3rd octet in this network that began with a 16-bit mask. So our new mask, it was a 16, so the new mask is going to be a /20, And I'm going to bring those subnets down here. We have x.x representing the first two octets. We have .0 and x.x.16 and x.x.32 and x.x.48. Those are our first four subnets. Now, because we are in the third octet, we have another 8 bits to represent over here that are all host bits. So a total of 12 host bits. These 4 here from the third octet, plus all 8 bits from the last octet for host addressing. Now, I did throw you a little bit of a curveball because we are no longer in the last octet. We are in the third octet that we're actually stealing bits from. So if we wanted to calculate the first valid host address on these subnets, how would we do it? And the answer is the same exact way that we did it before. Our first task is to list the subnets. Well, here's the first 4. That's done. The first host is going to be the subnet +1, and we add that +1 to the last octet. So this network of x.x.0.0, the first valid host, I'll write first here, is going to be x.x.0.1. That's our first valid address. The first valid address for the 16 subnet, I'm going to leave off the x's, by the way. I'm just going to leave an arrow down there. The first valid host on the 16 subnet is going to be 16.1. The first valid host on the 32 network is going to be 32.1. And the first valid host on the 48 network is going to be 48. And you got it. We're just simply going to add 1 to the last octet, 48.1. So piece of cake! We've got the first valid IP address on each of those subnets. The next question, what is the last valid IP address? Or we might even want to go for the broadcast address first, if you want, and then we could simply subtract 1 more from that for the last. It really doesn't matter in which way you do it, as long as you're comfortable with the process of what you are doing. So let's say for the 0 subnet, that's right here. Our first subnet is subnet 0. The first valid host address is 0.1. And I think the broadcast address is going to be the next subnet -1. You know why I think that? Because that's exactly how that works. Right here. The broadcast address is the next subnet -1. So if we wanted to look at the next subnet, which is 16.0, what is 16.0 -1? It's going to look like 15.255. And let me show you that in binary. In the third octet, we have 4 bits that are on. And then in the last octet, we have 8 bits that are on. So that is 15. And that is 255 right there. And our mask is right here. So my question is, what happens if you add 1 more, +1 right here? Well, all of these are going to carry over. So the +1 is going to topple all of these to zeros. This is going to turn to 16 because they're all going to topple over. And that's the binary behind it. So 16.0 -1 is 15.255. You simply put 255 for the last octet, and you take this number and say -1. So the next question is, okay, what's the last valid host on the 0 subnet? Well, it's the next subnet -2. So if the broadcast is 15.255, this last IP address is going to be 15.254. So our range of valid IP addresses on the 0 subnet is going to be whatever those first 2 octets are, 0.1, through whatever those first 2 octets are, 15.254, with a broadcast address of 15.255. Let's go ahead and do that same game again, and let's do it for subnet 32. And we can follow these exact steps. So on the 32 subnet, the first valid host is 32.1. The last valid host is going to be the next subnet, which is the 48 subnet -2. And -2 would be 47.254. And the broadcast would be 47.255. And then the next subnet, of course, is 48. So here's our first, here's our last, and here's our broadcast address for the subnet. For this next one, let's go ahead and use a /8. So our network is x.0.0.0. Our host bits are going to start in that second octet with a /8. And let's say we need to create 120 new subnets. So with the finger game, we get our thumb out, we start counting 2, 4, 8, 16, 32, 64, 128. I have 7 bits, or 7 fingers up, that represent that's how many bits it would take to create at least 120 new subnets. So our new mask is going to be 7 bits into that second octet, right there. So there's the dividing line. So our new mask is going to be 7 bits above and beyond the 8 bits we started with, which is 15. That new mask would be represented as 250 in dotted decimal as 255 dot and 254 for that second octet, which simply means that the mask is taking the first 7 bits of that second octet for the purpose of network address. So let's go ahead and list our subnets and the ranges. Now, we can have a whole bunch of subnets. In fact, we're going to have the ability to have up to 128 subnets. I don't want to list all 128, but let's go ahead and list like 4 or 5 of them to get the feel for it. So the first subnet is going to be subnet 0. And then our block size, because it's a 2, the next subnet is going to be 2, and then add 2 more, and add 2 more, and add 2 more, etc., etc. So that's our block size, and that's why we're adding that. And those are our subnets. So our subnets are going to be x dot, x dot, x dot, x dot, x dot, with that x being whatever it was. It could be a 10, it could be a 40, it could be a 195. Whatever it is, it's going to stay that way. Now, because this is the second octet where we're doing our custom subnetting, we still have 2 more octets of zeros, so we'll put them in as well. So there's our first 5 subnets. Subnet 0 would be our first, and then we have second, third, fourth, and fifth. We could also refer to them as subnet 2, subnet 4, subnet 6, etc. So now, let's go ahead and let's determine what the actual valid ranges are for each of these subnets. In fact, let's go ahead and just pick on subnet 2 just for a moment. And what I'd like to do is for subnet 2, let's identify the first host, the last host, and the broadcast address for subnet 2. The rules are exactly the same. We've listed our subnets. That's already done. We've got 5 of them right here. For the first host for subnet 2, it's going to be 1 more than the actual subnet value itself. So the first host is going to be x.2.0.1. And that's the first valid IP address on subnet 2. Now the last valid IP address is going to be the next subnet -2. And the broadcast is going to be the next subnet -1. Whichever one you want to do first, you absolutely can. So let's do the last address. That would be x.4.0.0 -2. So that would look like this. x.3.255.254. And that is the last valid IP address on subnet 2. And the broadcast address is going to look just like the last IP address, except it's going to be 1 greater than. So the broadcast address is 1 greater than the last IP address, and it happens to be 1 less than the very next subnet. Let's do one more. Let's go ahead and do it for subnet 6 right here, which is our 4th subnet. And what I would like you to do is go ahead and pause me right now. I'd like you to write out what is the first valid host for this 4th subnet, and what is the last valid host, and what is the broadcast, using the same exact process that we just went through together. So pause me right now. When you're done, unpause me, and we'll compare notes. So for this 4th subnet, which is subnet 6, the first valid IP address is going to be x.6.0.1. It's the subnet +1. The last valid host is going to be the next subnet -2. So that next subnet value is x.8. So it's going to be x.7.255.254. That in measurable terms is the next subnet -2. And our broadcast address is 1 less than the next subnet. So that would end in .255. It'd be x.7.255.255 for our broadcast. And that's it. What we've done in this video together is we've identified for an 8-bit or a 16-bit or a 24-bit mask how we would go about identifying not only the subnets but also the valid IP addresses of hosts that could be in those subnets. Here's our action items for this video. Number 1, of course, is you need to make sure that you've participated in the exercises in this video about calculating the first valid IP address and the last valid IP address for a given subnet. Secondly, go back to the opt-out questions at the very beginning of this video just to validate that you can now correctly and comfortably answer each and every one of them. I have had a great time, and I absolutely appreciate the time that we have spent together. I hope this has been informative for you, and I'd like to thank you for viewing.